Welcome to lesson number 1 of trigonometry. This is found on page 57. Now, we're going to start with looking at investigation number 1, and I've already started the investigation just to save some time on the video, and I'll show you what I was doing. So, in this example, what we need to do is take a look at this triangle. Now, this triangle OB1A1 is similar to OB2A2. So this small triangle that I'm outlining here, again, is similar to the triangle that it is inscribed into, which is this bigger one like this. All right. And what I then did was I measured A1, B1, which would be from here to here. This would be A1, B1. And that would, when I measure that, you get 1.4. And then we measured O to A1, which is 2 centimeters. Now that ratio of this side length to this side length is equal to 0.7. And with the next triangle, it has the same ratio. And from 2.8, so A2 to B2 we measured, we get 2.8 centimeters. And then from O to A2 we also measured, and that is 4 centimeters. And it has the same ratio, 0.7. And then we did the same thing with A3 to B3 and over O to A3. So B3 to A3, we get 4.2. O to A, we get 6 centimeters. And again, the ratio is 0.7. Now I left the last one blank intentionally so we can measure it together here. So from A4 to B4, I get a measurement of 5.6. And from O to A4, I get a measurement of 8. Now, if we put that in our calculator, 5.6 divided by 8, we get a ratio which is 0.7. And that is what would go here, 0.7. So from looking at this, we can conclude that the ratio 0.7 is somehow connected to this angle found in our triangle of 35 degrees. What we're looking at are trigonometric ratios. So trigonometric ratios. Now, if we have a triangle such as triangle AOB as shown, we're going to let the angle AOB be represented by x degrees. So this is the angle in question here. So each of the sides of the triangle is given a name relative to this angle. So the longest side, and that's going to be OB, this is referred to as the hypotenuse. And abbreviated, we would call it HYP, the hypotenuse. The side opposite the angle, so here's my angle straight across from it, so opposite, if you're standing here and you're looking at the opposite side, that would be right here, that is known as opposite. And then the side OA, the third side, relative to this angle x, is adjacent. Now, any of these locations can change depending on which angle we're talking about. We're never going to be really referring to the right angle unless we're talking about the hypotenuse, which is always directly opposite of the right angle, so the one that has the square labeled on it. However, we could have been referring to this angle, ABO. If we did that, then the sides of our adjacent and opposite would change. So let's look at class example number 1. So mark on each of these triangles the hypotenuse, the opposite, and the adjacent relative to angle x degrees. So relative to angle x degrees, this is where we're at. The opposite side of this is going to be over here, which means the side adjacent or right beside is right here. And remember, our hypotenuse is always opposite of our right angle, so that is right here. And the hypotenuse also happens to be our longest side length. Now our angle has changed locations. Now we're looking at x degrees here. So our angle opposite of, our side length opposite of x degrees will be found right here. So now this is opposite, and our side length adjacent to this angle, or right beside this angle, is right here. The reason this can't be adjacent is because it's the hypotenuse. The hypotenuse is always the longest side and is always opposite of my 90-degree angle. Now, I want you to read the section below this, and I'm gonna go to class example number 2, again for time of this video. Now, in class example number 2, you're introduced to this mnemonic, SOHCAHTOA. SOHCAHTOA. This mnemonic is gonna come in extremely useful, and you're actually gonna use it all the time from now until pre-calculus 12, as well as physics 11 and 12. You're always gonna use this mnemonic whenever you're using right angle trigonometry. So memorize this, and I'll show you why. So the diagrams shown below are the same ones from the previous example. We want to complete this and work to list the sine ratio, the cosine ratio, and the tangent ratio for our angles x. Now, we want to list the sine ratio for the angle of x degrees. So here's my angle, and I want to know the opposite divided by the hypotenuse. So my opposite sine of x, or the opposite side, is going to be found right here. The hypotenuse is here, and then my adjacent is right here. The side length right beside my angle, which is not the hypotenuse. That's the adjacent side. Now what we want to do is we want to say what these side lengths are. So the opposite side was side D to E, DE, and that's divided by the hypotenuse if we're looking for the sine ratio. So my hypotenuse was E to F, or F to E, E to F or F to E. The cosine ratio is the adjacent side, which is D to F, divided by my hypotenuse, which was E to F. And my tan ratio is my opposite over my adjacent, which was DE over DF. And we're going to do the exact same thing with this side over with this triangle here. The sine ratio for angle x, so here's the angle in question. The sine ratio, so before we actually even label anything, we want to say where, or sorry, before I label any of my ratios, I want to label the sides of my triangle. So now this is the opposite, because it's opposite of my angle. This side here is the adjacent, because it's right beside my angle, and it's not my hypotenuse. And then over here is my hypotenuse, because it is opposite of my 90-degree angle. Now, sine ratio is always, sine, opposite over hypotenuse. So it's always opposite over hypotenuse. And in this case, my opposite is SV. SV over hypotenuse, which is TV. TV. My cosine ratio is Ka. Cosine, adjacent over hypotenuse. Adjacent over hypotenuse. And my adjacent is ST divided by the hypotenuse, which again is TV. And lastly, my tangent ratio, tangent, opposite over hypotenuse, is equal to SV, that's opposite, and tan ratio, adjacent, my mistake, make sure we clear this up. Opposite over adjacent is always tan ratio. And my adjacent was ST, so SV over ST. Now, where do we actually use those? How does that give us a ratio, a sine ratio? Well, if we look at class example number 3, there is an example with numbers. So we want to complete the work to express the primary ratios in relative to angle A with rational numbers and in decimal form to the nearest thousandth. All right, so let's take a look at this one. Sine ratio is relative to angle of A degrees. So my opposite side is right here. this is my adjacent, and then this is my hypotenuse. So opposite over hypotenuse would be 20 over 29. Now we want to express this as a decimal. So 20 divided by 29 to the nearest thousandth is going to be 0.689. And we could round this to 0.690. Either one of these answers will be acceptable. Cosine ratio relative to angle A. Remember cosine, if we write our mnemonic up here, so katoa, cosine is adjacent over hypotenuse. So our adjacent side is 21 and our hypotenuse was 29. So 21 divided by 29, we get 0.724 to the nearest thousandth. And finally, my tan ratio, which is opposite divided by adjacent. So opposite divided by adjacent is equal to my opposite side, which was 20, and my adjacent side, which is 21. 20 divided by 21. 20 divided by 21 is equal to 0.952. 0.952 to the nearest thousandth. Now consider our triangle PQR as shown. The sine ratio for the angle of x degrees is PR divided by PQ is equal to 3 over 5. In short, we can write it like this. Sine x degrees is 3 over 5. So similarly, the cosine ratio, which would be my adjacent, so here's our angle, and so this is why it's always good to label our triangles. So this is our opposite side, meaning this is our adjacent side, and this is our hypotenuse. So cosine ratio would be, again, let's write our mnemonics, so katoa. So if I'm looking for cosine, that's adjacent over hypotenuse. Adjacent over hypotenuse, which is going to be QR over my hypotenuse, which is PQ, which is going to be 4 over 5. Oh, so I should have said and. Okay, never mind. And tan x is equal to, well, tan, opposite over adjacent. So opposite was PR over adjacent, which was QR. PR is 3, and QR is 4. So sometimes our trig ratios for an angle are given in terms of the letter at which the angle is located. For example, PQR above, we could write sine Q as well, all right? So our sine ratio, we could have, even though we wrote sine X or sine PRPQ, we could have also referred to it as sine Q. This refers to this angle here attached to this point, this vertex.